Welcome to the Blitz edition of Square Roots Part 1 by me, Philip Brown. I'm the Bearded Math Man. Now this is a Blitz edition, so it will be fast-paced, and it's best used as a review. Feel free to pause so you can think or take notes, and as always, the most important part of review is reflection. So there are some questions at the end, not math questions, but there are questions at the end that you should take a moment to think about. And for some practice, just look at the video's description and find the link there. Let's get started. Square roots, part 1. Now, square roots are a very elusive and frustrating topic for students. And the reason that is because students are so focused on the procedure, how to simplify a square root, that they don't spend much time really reading or understanding what square roots are. And the key to understanding square roots is to be able to read square roots as a question. A square root, what it really means is, I've got a square whose area is this number, the radicand. And this is asking a question. What is the length of a side? So, for example, if we had a square and its area was 16, we would know that since it's a square, all the sides are equal, and the way you find this area is you multiply the two sides. Since the sides are the same, and you multiply a number times itself, it's called squaring it. No coincidence there. We're looking for what number squared equals 16. So, of course, this one, would be 4. So again, the big idea here is that when you have a square root, it's asking a question. The question it's asking is, what number squared equals this? Now sometimes you can't actually write out what number squared equals the radicand. So for example, the square root of 2 is irrational. It doesn't repeat, there's no pattern, it is a decimal that goes on forever and ever. And so the accurate way of representing that number is by the square root of 2. So this gets a little touchy and this gets tricky and students get confused with the irrational numbers, but just know that if you're dealing with the square root of a prime, it's irrational. Worth repeating. The square roots ask a question. What number squared equals the radicand? And, in case you don't know, the radicand is the number inside the square root symbol. The square root equals a number if that number squared equals the radicand. Yep. Look at this again. Let's make sure this makes sense. The square root of n will equal the number k, only if k squared equals n. Now, n is the radicand. It's different than the square root of n. Students often write square root of 5 as if it's the same thing as 5, and it's not. 5 is 1, 2, 3, 4, 5, and the square root of 5 is a number times itself that equals 5. Totally different things. So you have to make that distinction very clear. Square roots are looking for a number squared that equals a radicand. The smart way to simplify a square root is to factor, but not factor completely and not prime factorization. You need to factor and you need to look for perfect squares. You got to look for perfect squares. So let's look at an example over here. On the left, we're going to do it the smartest possible way, and on the right, we're going to try some other ways that you can still get the right answer. They're not wrong, but they're inefficient. So the square root of 24. The biggest perfect square that's a factor of 24 is 4. Here are the other ways we could factor 24. 2 times 12, 3 and 8, and 2 times 2 times 2 times 3. This way is the best. Now, a lot of the time, students are taught to do prime factorization, and then they look for a pair, and they take a pair out. And I really think that is low-quality teaching, and I'm sorry to say so, but it really is because it takes students away from the meaning of the math. I prefer that students write it this way, just because it's more natural when you take the square root of 4, which is just equal to 2. That seems to be the smoothest way to do it. Now, square root of 4 times the square root of 6, you could write it the other way. But since we're going to be putting our natural numbers in the front for multiplication, it's better to write it this direction. Now, you could do it this way as well, right here. The square root of 4 times the square root of 6. Same thing. This and these two right here are all the same representation. This will be true. The square root of 24 will equal 2 times the square root of 6 if 2 root 6 times itself equals 24. Now again, we're not talking about equaling the square root of 24. We're talking about equaling the radicand 24. The order in which you multiply numbers doesn't matter. There's the commutative property. So 2 times 2 and the square root of 6 times the square root of 6. That's how we're going to do this right here. So 2 times 2 is 4. The square root of 6 times the square root of 6 is the square root of 36, which is, of course, 6. 4 times 6 is 24. And there we go. See? 2 root 6 times 2 root 6 equals 24. So this is absolutely correct. The big idea, once again, square roots are asking what number squared equals a radicand. And the smart way to simplify them is to factor that radicand looking for a perfect square. And the bigger the perfect square, the better. Now let's take a look at a number that has 2 perfect squares that are factors. So when we look at the square root of 48, you see we've got 4 times 12 and 3 times 16, and either number would work. However, 3 and 16 will be easiest. Now we can get the right answer from using the factors 2 and 24 or 6 and 8, but we don't really want to. It's going to be much more complicated. You're probably going to fumble around with the simplification of 24 or 6 and 8 and just mess it up. So give yourself a moment and find the biggest perfect square. 4 and 12, it does work. So does 16 and 3, but this one's better because 16 is larger. So let's take a look. 16, the square root of that is 4. So 4 times the square root of 3, we're done. 3 is a prime number, cannot be simplified. We are finished. 4 and 12. All right, the square root of 4 is 2. Yes, but here's why we're not done. There's a factor of 12 that's a perfect square. It's 4. 4 times 3 is 12. Square root of 4 is 2. 2 times 2 is 4. And then we're done. Much more work over here. So that's going to take longer. And the more steps you take, the more chances you have to make a silly mistake. So find the biggest perfect square first. It's much easier. You might not realize that the square root of 400 is 20, but you might see that 4 times 100 is 400, and that's pretty easy. Square root of 4 is 2, square root of 100 is 10, so 20. The reason I mention this is either way that you do these problems, you can still get the right answer. It's not the end of the world if you miss the biggest perfect square, but you should really look for it. All right, now let's talk about what happens if you got some variables. So we've got here the square root of 50x cubed. Now 50, that's an easy one because it's 25 times 2, and 25 is a perfect square. But the part you might not be realizing is that x squared is also a perfect square. And x squared times x would give you x cubed. Well, that's what we're looking for, biggest perfect squares. Now here, it's kind of hard to write this out. I didn't put it so that there's a perfect square and another perfect square and then not perfect squares. I have it perfect square and then another number and then a perfect square and another variable. There's our perfect squares though. Now the square root of 25 is 5 and the square root of x squared is x. And we're left with the square root of 2 and the square root of x. So this is our answer right here. It's 5 times x times the square root of 2x. So square root of 25 is 5. The square root of x squared is x. And we don't know what the square root of 2 is. Well, it's irrational. And we don't know what the square root of x is. So we have to leave it like that. We can check this by just taking our answer and squaring it. So 5x times 5x and the square root of 2x times the square root of 2x. That gives us 25x squared. This gives us the square root of 4x squared. Square root of 4 is 2. The square root of x squared is x. Putting it all back together, multiplying, yep, 50x cubed. This squared, 5x times the square root of 2x, does equal 50x cubed. So that's how I know it's the right answer. The last question we're going to tackle is, how do you know when you're done? I've got 2 square roots right here. One is finished, nothing can be done, and one is not finished, something can be done. So this one over here is complete. And the reason why it's complete is because the factors of 6x are 2, 3, and x. So the square root of 6x is the square root of 2 times the square root of 3 times the square root of x. There are no factors of 6x that are perfect squares. So this one's done. This one's not done because 8 has a factor that's a perfect square, 4. The square root of 4 is 2. This would be done, but this is not. The idea here is that if the radicand contains a perfect square, you can do more simplification. If the radicand does not have a factor that's a perfect square, you're done. I hope this video has been helpful. I hope you've learned a lot about square roots. Number 1, that a square root's asking a question, what number squared is the radicand? Number 2, that the way you simplify them is you factor and you look for the biggest perfect square. And number 3, that you are done when the radicand does not contain a factor that's a perfect square. Take a few moments. Think about this. What did you already know? What did you see that you forgot that was like, oh yeah, I got that. Not too bad. And what's still confusing? Because if there's something still confusing, you need to do a little bit more work. If this video was helpful or useful or interesting and entertaining, you could really help me out by sharing it on social media, clicking like, telling your friends about it, and maybe even subscribe to my channel. Anyway, thanks for watching.